Hello and welcome back to Study Room. So in today's video lecture, we are going to learn about solving equations having the variable on both the sides. We have learned how to solve the equations with variables in only one side. Now we will proceed to learn solving equations that have variables on both the sides, that is on both the left and the right hand side. How do we solve such equations? Just as numbers, variables can also be transposed from one side of the equation to the other. We have an example here. Example is solve 6x minus 3 equals to 2x plus 5. So what is our first step in solving such equations? We transpose all variable terms to one side and the numbers or the constants to the other side. So this was given to us as 6x minus 3 equals to 2x plus 5, and we transported 2x to this side and minus 3 to this side, and it became 6x minus 2x equals to 5 plus 3. So our first step in order to solve such equations is keeping all the variables to one side and all the constants to the other side. The next step involved is now perform mathematical operation on like terms. Here subtract 6x and minus 2x and add 5 plus 3. So in the next step, what do? We do perform mathematical operations on the like terms. So here, since both these terms contain variable, we are going to subtract these terms, and since both these terms are constants, we are going to add both of these together. We'll get 6x minus 2x as 4x and 5 plus 3 as 8, so 4x equals to 8. What is our step number 3? In step number 3, we are going to divide both sides with the coefficient of variable. So the coefficient of our variable here is 4. So we are going to divide both the left hand and the right hand side by number 4. It becomes 1 by 4 into 4x equals to 1 by 4 into 8, and the answer comes to be x equals to 2. So x equals to 2 is the solution of this equation that had variable on both the sides. So these are the three steps. These are the three steps that are included in solving equations having variables on the both sides. Now let's just solve such an equation. The equation in this example number 12 given to us is 2x minus 3 equals to x plus 2. Just remind the first step. Our first step was to keep the variables on one side and keep the constants on the other side. So we will bring x to this side, it will become 2x minus x, and minus 3 will go to that side and become 2 plus 3. Now the second step was to perform the mathematical operations on the like terms. So since both of these terms have variables and both of these terms are constants, we are going to perform this operation on these terms and this operation on both of these terms. 2x minus x will become x and 2 plus 3 is going to be 5. So x equals to 5 is our solution for this equation. We did not have to perform the step 3 here because the coefficient of x here is 1. So 1 divided or not divided remains the same. Next is example number 13. We need to solve 5x plus 7 by 2 equals to 3 by 2x minus 14. Again, bring both these terms having variables to one side. It will become this, and these will become minus 14 minus 7 by 2. Solve it. We will solve it by taking example. What will it be? 2. This will become 10x minus 3x, and this will become 2 minus 28 minus 7. 2 when divided, 2 and 2 are going to be cancelled here. So it will be 10x minus 3x equals to minus 28 minus 7. Now we need to perform the mathematical operations on the like terms. So 10x minus 3x will be 7x, while 28, both are negative numbers. We will be adding these numbers. That will be 35 with the minus sign. This will be minus 35. Now our third step, that was to divide both the sides by the coefficient of the variable, that is x, and the coefficient here given is 7. So we will be dividing both these sides by the number 7. This will become minus 35. You can see it will be x equals to, when this minus 35 divided by 7, that is 5 with a negative sign. So our answer for this equation, or our solution for this equation, is x equals to minus 5. You can check this by putting minus 5 in the place of x and you will get both the left hand side equal to the right hand side. What is our next example? Our next example is example number 14, that says the digit of a two-digit number differ by 3. If the digits are interchanged and the resulting number is added to the original number, we get 143. What can be the original number? We need to find the original two-digit number. So just take an example that if we have a two-digit number and that number is 56, we can write 56 as 10 into 5 plus 6. We can write this number 56 as 10 into 5 plus 6. Now if the digits are interchanged, this number will become 65. The 65 can be written as 10 into 6 plus 5. Similarly, if we let number or let the digit at ones place, the digit at ones place equals to b. It is said that the digits of a two-digit number differ by 3. So what will be the digit at tens place? The digit at tens place is going to be b plus 3. We concluded it from this statement that the digits of a two-digit number differ by 3. So if one of the digit is b, the other one will be b plus 3. So what is our number? What is our original number coming to be? Original number is equal to the digit at tens place multiplied by 10, that is 10 into b plus 3 plus digit at ones place. Similarly that we did here. What we did here? 10 into the digit at tens place plus the digit at ones place. So it is 10 into b plus 3 plus b. That is 10b plus 30 plus b, or you can write 11b plus 30. This is our original number. This is our original number. Therefore, our original number is coming to be 11b plus 30. Now, what if the digits are interchanged? If the digits get interchanged? Digits get interchanged. Then, when digits get interchanged, then the digit at ones place will be b plus 3, while the digit at tens place is going to be b. Therefore, our new two-digit number is going to be 10 into b plus b plus 3. Just like this. This is going to be 10b plus b plus 3, that is 11b plus 3. So you can see from here, I will write it again, that just check it once. I am writing it again. So our original number is this 11b plus 30, and our new number is coming to be 11b plus 3. That is, I'll write it again here. Original number, the original number was 11b plus 30, and the new number after interchanging the digits is coming as 11b plus 3. Now what does the other part of the question, what does the other part of this example says? Just read it once. The second part of this question says that the resulting number when added to the original number, that is when the new number is added to the original number, we get 143. What can be the original number? Finally, we need to find the original number. So according to the question, when this number and this number, both of these numbers are added, 11b plus 30 is added with 11b plus 3. We are getting what number? We are getting 143 as the answer. We need to find the original number. That is, we need to find the 11b plus 30's value. Solve it. It will become 11b plus 11b. 22b plus 33 is equal to 143. 22b, 33 will go to the other side and it will become 143 minus 33. You can do it in the rough side. It will be 143 minus 33. It is 0 and this is 110. So it becomes 22b equals to 110. Finally, you can divide both the sides by 22 and you will get your b as 110 by 22. And that is nothing but, this is going to be, you can divide it by 11 as well. 2, 11, 10. It's coming as 5. So our b is 5, but this is not the solution that we had to find. We had to find the original number. What was the original number? Original number was 11b. I'm writing it here. Okay, I'll write it here. Original number was 11b plus 3. Sorry, 11b plus 30. Original number was 11b plus 30. That will be 11 into b's value, that is 5 plus 30. That is going to be 55 plus 30 and that is nothing but 85. So what was our original number? Our original number was 85. You can even check this answer. How will you check this answer? You will do everything that is written. You will do all these steps. You will, first of all, you can see that 8 minus 5 is 3. So this condition is satisfied if the digits are interchanged. That is, if this number becomes 58, and if you add both 85 and 58, you will get 143. So you can say that yes, 85 is the original number. 85 was the original number that we had to find. Now our example number 15 says that Arjun is twice as old as Shriya. 5 years ago, his age was 3 times Shriya's age. We need to find their present ages. Just like the previous examples, we will let Arjun is twice as old as Shriya. Just let Shriya's age be x years. Then Arjun's age will be what? Arjun's age will be 2 times x because it is twice as old as Shriya. It will be 2x. 5 years ago. So 5 years ago, what will be the ages? Shriya's age will be 5 years ago, before 5 years. So if right now I am 10 years old, 5 years before I was, 5 years ago I was 10 minus 5. That is 5. Similarly, Shriya's age 5 years ago was x minus 5. And similarly, 5 years ago, Arjun's age was nothing but his present age minus 5, that is 2x minus 5. According to the question, what does the question say? What does this example number 15 says? It says that 5 years ago, his age was 3 times Shriya's age. That is, Arjun's age, 2x minus 5, was 3 times Shriya's age. That is 3 times x minus 5. We need to find their present ages. That is, we need to find x and then 2x. We'll solve this. It will become 2x minus 5. Just solve this bracket. It will become 3x minus 3 into 5, 15. We'll keep both the variable terms on the one side and the constants on the other side. This will become 3x minus 2x. You can just interchange the sides. Okay, it will become 3x minus 2x and equals to 15 minus 5. That is, now do these mathematical operations on the like terms. This is 3x minus 2x, that is x, and 15 minus 5 is 10. So this is x, and x was Shriya's present age. So what is Shriya's present age? Shriya's present age is 10 years. Then what is Arjun's present age? Arjun's present age is 2x, that is 2 into 10, and it is 20 years. So Arjun's age is 20 years while Shriya's age is 10 years. And we found out these. So this is how we solving these examples. Okay, so we have one more topic in this video lecture, and it is reducing the equations to simpler forms. You can just check this thing from this example, example number 16. You can just see that the equation given here is very complex. It's in a rational form. Then we have this variable term along with the constant term, and on the other side we again have some variable term. How will we go solving this? We will just first of all simplify this complex equation. How can we do it? You can check that if we multiply 6 on both these sides, multiplying 6 both these sides, it will become 6 into 6x plus 1 by 3 plus 6 into 1. This will become 6 into x minus 3 by 6. You can check out that this will be divided by 3. This 6 will be divided by 3 and it will become what? 2. 2 into 6 plus 1 plus 6 into 1 is 6, and this 6 will get cancelled by this 6. This becomes x minus 3. Now solve this bracket thing. This will become 2 6, that is 2 6 are 12x plus 2 1s are 2 plus 6 equals to x minus 3. You can again still solve this. This is 6 plus 2, that is 8 equals to x minus 3. Now our second step is to keep the variable terms on the one side and keep the constants on the other side. It will be 12x minus x equals to minus 3 minus 8. Solving this will become 12x minus x, that is 11x equals to minus of 11, and x is coming to be minus 1. After dividing minus 11 by 11 we get minus 1, and that is the solution of this whole complex equation. So first of all we simplified this complex equation and then we applied all the steps that we had to use when we are solving equations having variables on both the sides. We again have one more complex equation, and this is 5x minus 2 into 2x minus 7, that is equal to 2 into 3x minus 1 plus 7 by 2. We can simplify this by first of all solving the brackets. So this left hand side is going to be 5x minus 2 into 2 is 4x, minus into minus will be plus, 2 7 are 14. Solve this bracket as well, it will be 6x minus 2 plus 7 by 2. Now just keep, you can still solve this. 5x minus 4x is going to be, 5x minus 4x is going to be x plus 14, and this whole is going to be 6x minus 2 plus 7 by 2. Now keep the constant terms on one side and the variable terms on the other side. This will be 6x minus x equals to 6x minus x equals to 14 minus 7 by 2 plus 2. Now apply the mathematical operations on the like terms. We are getting 6x minus 6, that is 5x, and this we can take the LCM here. After taking LCM we are getting 28 minus 7 plus 4. After solving this we can get 28 plus 4, that will be 28 plus 4 will be 32, and 32 minus 7 will be what? 12 minus 7, that is 5, and 25. It is 25 by 2. Solving this gives us 25 by 2, and now our third step, that is to divide both the sides by the coefficient of the variable x, that is 5. Dividing both the sides by 5 gives us 25 by 2 divided by 5, that is, this will get cancelled and it becomes 5 by 2. So what is the solution of this complex equation? It is x equals to 5 by 2, and this is the solution of this example number 17. You can check this by putting the value 5 by 2 in the place of x everywhere, and you can see that left hand side will be equal to the right hand side. Therefore, this is the solution of this whole equation. What is our next example? Example number 18 is solve x plus 1. This is nothing, x plus 1 by 2x plus 3 equals to 3 by 8. This is again a complex equation. We will be simplifying it first. How can we simplify it? Just think. You can cross multiply these terms. After cross multiplying, you will get 8 is multiplied by x plus 1, and here 3 is multiplied by 2x plus 3. What will you get? Now solve the brackets. 8x plus 8 equals to 3 to 6x plus 3 are 9. Now our next step is to keep the variables on one side and the constants on the other side. This will be 8x minus 6x equals to 9 minus 8. You can check that this becomes 8x minus 6x is 2x, 9 minus 8 is 1. Now, third step was to divide both the sides by the coefficient of x. Here it is 2, so we'll be dividing both the sides by 2. This will become 1 by 2. So, x equals to 1 by 2 is the solution of this equation. You can check this by putting the value 1 by 2 in the place of x. So, we have a statement question next. Example number 19. What does it say? It says that the present ages of Anu and Raj are in the ratio 4 by 5. 4 is to 5. 4 is to 5, okay? And 8 years from now, the ratio of their ages will be 5:6. We need to find their present ages. So if the present ages of Anu and Raj are in the ratio 4 by 5, we can say that we can let Anu's age, present age, be 4x. If Anu's present age is 4x, then Raj's present age will be what? 5x. You can check this because 4x raised to 5x is nothing but 4:5 that was given to us. Now 8 years from now, what is going to happen? 8 years from now, or after 8 years. 8 years from now, what is happening? 8 years from now, the ratio of their ages will be 5:6. So 8 years from now, what will be Anu's age? Anu's age will be present age plus 8. That is 4x plus 8. And what is Raj's age at that time? After 8 years, Raj's age is going to be present age, that is 5x plus 8. It is given that after 8 years, the ratio of their ages is 5:6. So according to the question, we can say that 4x plus 8 by 5x plus 8 is given us to be 5/6, 5:6. Again, we have got a complex equation. We are going to solve it by simplifying it. You can simplify it by cross multiplying. We'll cross multiply. We'll multiply 6 by 4x plus 8, and this number 5 will get multiplied by 5x plus 8. Solving it, you will get 6 4s are 24, x plus 8 6 are 48 equals to 25x plus 5 8s are 40. I'm erasing this part. Now, how can I solve this? I again need to follow all the steps. So our first step was to keep the variables on the one side and the constants on the other side. This will be 25x minus 24x, which will be, x is going to be 48 minus 40. Now apply the mathematical operations on the like terms. 25x minus 24x will be x, and 48 minus 40 is going to be 8. X is coming to be 8, but we have to find their present ages. Now Anu's present age was 4x. We let Anu's present age as 4x and Raj's present age as 5x. So after putting x as 8, Anu's present age is coming to be 4 into 8, that is 32 years. 32 years. 4 multiplied by x, that is 4 into 8, that is 32 years. And what will be Raj's age? So Raj's age was 5 into x, that is 5 into 8, that is 5, it's a 40 years. So this is what we had to find their present ages, Anu's and Raj's present ages. We let them as 4x and 5x. After finding the value of x by simplifying and then solving this whole equation, we found out that x was 8, therefore their present ages will be 4 into 8, that is 32, and 5 into 8, that is 40. This is how we solved it. This was all about this video. In the next video, we are going to do a quick recap of all the topics that we did in our chapter 2 of class 8 mathematics. We'll join in the next video. Till then, have a good day. Take care. Bye bye.